Welcome to today's statistics tutorial. Today we're going to be looking at normal distribution percentile questions and looking at how to solve when they ask for percentiles, quartiles, IQR, and any type of problem where they give you the percentage and ask you to solve for an X value or a Z-score. To solve for percentile questions, we're going to use the inverse probability on this calculator. So let's look at our first question. It says find the 90th percentile. So what does that mean? If we draw our picture, if we draw our graph, then what that tells us is that we are looking for, or we're given, the 90th percentile, which is the same as saying 90%. And we want to find what is that X value that matches right here at this point. What is that value that's going to give me, or the X value that's going to give me a 90th percentile? So to solve that, we're going to use our inverse probability. So we're going to use this second set of calculations. We're looking for the probability of some X value that's going to give me 90%. And we're going to write our number in as a decimal. So I'm going to put 0.90 into my calculator. And we're going to go ahead and we'll use an example of a mean of 24, standard deviation of 6. So we check our calculator. We've got it marked for normal distribution. We've got our mean of 24, standard deviation of 6. Those are typed in. We're going to use our inverse probability where we're looking for the values of X that are going to give me the 90th percentile. So this is going to means that somewhere between X, that X value and less, that's going to give me my 90th percentile. So I'm going to calculate, and we see that it's giving me an answer of 31.6893. So that tells me, this answer in red is telling me this X value right here where the purple and the white meet, that's my X value, and that is going to be the X value that will give me a 90th percentile probability, and the 90th percent probability is this purple shaded area. So this value, this unknown value here, that is 31.6893. Our next problem asks us to find the upper 10%. So if we are to graph that, we are looking at the upper 10% probability, and once again we want to find what is that X value that is going to give me this 10%. And the upper 10% is going to the right. So let's use the same values, a mean of 24, standard deviation of 6. This time we're looking for values that are greater. So we're going to look at the probability that the X values are going to be greater than some number, and that is going to give me 10%. So we're going to use the second probability and type in 0.10, hit calculate. It's shaded to the right just like we would expect, and if you'll notice, it's going to give me the same value that I got before when I was looking for the 90th percentile. So these are opposites. And that's one of the things that you want to pay attention to is how is your question worded. If it just asks for a percentile, it's going to start at the 0 and go to the right. It's going to be how we solved for the 90th percentile, and that's going to be your top probability. That's going to be the most common that you're going to use. If they specifically ask for the upper 10%, then they're asking for a right-tailed test, and they want you to start at a value and go to the right. And you'll notice that if I hit calculate, the numbers are going to be exactly the same. If I switch to the 90th percentile, it's going to be shaded on the left. If I go to find the upper 10%, it's going to be shaded on the right. But that value that it's oscillating or rotating on, that value, that X value, is exactly the same. So you want to pay attention to how your questions are worded. That's going to help you to know which of these inequalities that you're looking for, and also your graph. Pay attention. It's helpful to draw it out a little bit before so to see if your calculator matches what you would expect. But this also tells you that it gives you some options for which of these probabilities that you're going to use, and you just need to know that these are opposite. And we know that these are opposite because if we're going to add these together, 90 plus 10, 90 plus 10 equals 100. And if this graph was completely full, that would be 100%. Our next question asks us to solve for the interquartile range, the IQR. So if you remember from when we did the box plots, that the IQR is just the middle 50%. So this is our IQR. And we got that the IQR is the middle 50%, and we get that by taking the third quartile range minus the first quartile. And the third quartile is 75%, and the first quartile is at 25%. So if you'll remember, this is 25%, 50% is our median or middle point, 75%, and our outer edges are 100% and 0%. So when we're solving for the interquartile range, for any other distribution, we're going to do the same setup. We're looking for the middle 50%. So at my mean is my middle number, and I'm looking for my Q1 and my Q3. My Q1 is going to be at 25%, and my Q3 is going to be at 75%. And I'm looking for what is this middle value. This is going to be my IQR, or my middle 50%. So the way that I solve that is I'm going to need to, so you'll notice on the calculator it doesn't have a range like we did when we were solving for the probabilities. So I need to solve for each of these quartiles separately. So what I'm going to do is I am going to solve for my first quartile, and then my third quartile. I'm going to solve for each of these quartiles, and then I'm going to take the difference. So let's take a look at what are we solving for. So this first one, we want to solve for, here's the median. We want to solve for this lower end. That is going to be my lower 25%. Then I'm going to solve for my Q3, and that's going to be this whole area, and that is 75%. And then I'm going to take the difference of these two. So this is what I'm solving for. So to get my Q1, that's at 25%. So that means I'm going to plug this into my probability formula. I'm going to take the probability of X, and I want to know what value is going to give me, and actually that's not even a question mark, that is my Q1. What value is going to give me my Q1, which is going to be 25%. So I'm going to type in 0.25, calculate, and that tells me that my Q1 value is going to be 19.9531. That's my Q1. Now I'm going to do the same thing, and I'm going to solve for Q3. My Q3 is at 75%, so I'm going to do the same thing, but this time I'm solving for my Q3, and I'm going to plug in 0.75%. So I'm going to change that to 75. And for all of these, we'll use the same mean and standard deviation. So let's write that down. Let's say we're given a mean of 24, standard deviation of 6, so that we're staying consistent with all of the problems that we have solved so far. Let's go ahead and hit the calculate button, and that is going to give me my value of 28.0469. So this is my Q3. So that tells me, so we've got our Q1, which is 19.9531. That's this value right here, and that tells me that 19.9531, that is the X value that I need in order to get my 25%. So between 0 and 19.9531, that whole area under the curve is my first quartile at 25%. My third quartile is right here at 28.0469. So all of the area between 0 and 28.0469, that is going to be 75%, and that is my third quartile. So now I want the IQR, so that is going to be the difference between those two values. So the IQR is going to be the Q3 minus Q1. So I'm just going to plug in those numbers. That's 28.0469. Subtract that from 19.9531. And that is going to give me 8.0938. So that tells me I think I'm running out of space here. There we go. So that tells me that on my graph here, if I have my Q1, I didn't draw that graph very well. Let's redo that graph. So on my graph, I have my middle value here. That's my M. Then I have my Q3, which is at my 75%. My Q1, which is at 25%. This value in between here, this difference, this is my 50%. That difference between those two values is going to be 8.0938. So my IQR is going to be 8.0938. So that tells me that the values between my Q3 and my Q1, so my Q3 was 28.0469 and my Q1 was 19.9531. That difference is 8.0938. So if you get an IQR problem, this is how you're going to solve it. So let's just kind of review this because this problem trips up a lot of people. So when you solve for the IQR, what you're looking for, there's 3 steps to this. So the first thing you need to do is you're going to solve for the first quartile. The first quartile is at 25%. So you're going to plug that into your probability calculator. And that's going to give you this point right here, where you're going to get 25%. Then you're going to solve for your third quartile, which is at 75%. So once again, you're going to use that first percentage, plug in 0.75, and get the value for your Q3. Then you're going to take the difference, and that's going to give you your interquartile range. That's your range. That tells you that there is a range of 8.0838 between your first quartile and your third quartile. Our last problem asks us to find the middle 20%. So this is going to be similar to how we solved for the IQR. Let's look at the graph as to what we're solving for. We want to solve for the middle 20%. So that means we want to find the lower boundary and the upper boundary of what are these two values. That in between, the probability in between is going to be 20%, give us a 20% probability. So let's go ahead and we'll use the same mean and standard deviation that we did before. So the first thing we need to do is we need to figure out our percentages. What are we solving for? So if I take 100% minus 20%, that's going to give me 80%. And then I divide that by 2, give me 40%. So that tells me in this white space, I've got 40% on the lower end and 40% on the upper end. So that tells me my lower boundary is at 40%, And my upper boundary is going to be at 60% because I've got 40% plus 20% is going to give me 60%. So now that I have my percentages, I know what I'm going to solve for. So let's draw the pictures. It's going to be similar to what we did with the interquartile range. I'm going to first solve for my lower 40% so that I can get my lower value. Then I'm going to solve for the upper boundary. So this is 40%. And this is 60%. So I'm going to solve for those two, and then I'm going to take the difference between those. I'm going to take the difference between the upper and the lower is going to give me my middle 20%. So this is what I'm solving for. So let's go ahead and put in my calculations. For my lower, to get that lower boundary, I'm going to get the probability that x is going to be less than my lower boundary, and I'm going to set that equal to 40%. And that is giving me a value of, that tells me my lower value is 22.4799. So this value right here where the purple and the white intersect, that is my lower value, and the shaded area is my lower 40%. Now let's solve for the upper boundary, which is going to be at 60%. So I'm going to change this to 60. Click on Calculate. And that is going to give me 25.5201. So once again, right here at the spot where the purple and the white meet, that is the upper boundary for my middle 20%. So now I'm going to take those two numbers. I want to get the middle 20%, and so that is going to take that upper boundary minus the lower boundary, and when I subtract those two values, that gives me 3.0402. So that tells me that the middle 20% equals 3.0402. So this would be the answer to my problem. Now there is a second way to solve this problem. And the second way is going to be very similar. So we're going to start out with our graph, just like what we did before, where we calculated we had 40% on the lower boundary, 40% on the upper boundary, and we wanted to solve for this middle 20%. So because we're solving for a lower and a middle value, and we've got an upper and lower percentage values, then what we can do is we can solve for the lower 40% and then solve for the upper 40%. So if I'm going to do that, the lower value, we're going to solve it exactly like we did before. So this time, I'm going to take my lower value, or to solve for that, we're going to take the probability x is less than my lower value, set that equal to 40%, and then when I plug that in to calculate, that gives me my 22.4799. Now when I'm doing the upper boundary, so remember that if I'm using this first probability, inverse probability, it's always going to give me a left-tailed test because it's going from 0 up to whatever my x value is. So now if I want to do the reverse and do an upper limit, get a right-tailed test, then I'm going to use this other probability. So if I want to get the x upper, I'm going to use, I want all of my x values that are going to be greater than my upper limit. I want to get the upper 40%. So the first one was the lower 40%. Now I'm solving for the upper 40%. And you'll notice it's the same, and this is because just like what we saw with our percentile questions, that if I'm getting the lower 60%, I'm going to have that same value as if I'm getting the upper 40%. Because when I add 60 plus 40, add those together, that's going to give me 100%. So if I'm solving for the upper 40%, I'm going to use the second inverse probability where I'm solving for values that are greater than my x. If I'm solving for the values that are less than, I'm going to use this first one, and I'm going to get that 60. It's going to go from 0 to my value. But then if you'll notice, my numbers are exactly the same. And then once again, if I want to get the middle 20%, I'm going to take that upper value minus the lower value, and that difference is going to give me my middle 20%. So that gives you two different ways to solve for any time that you have any type of two-tailed distribution where they want a middle portion of your graph. If you have a middle portion, then what you're looking for is you want these two endpoints. You want your lower boundary and your upper boundary of where those percentages are. And then you can either take the difference of two left-tailed tests, left-tailed percentages, or you can take the difference between the lower percentage and from the upper percentage. Those are going to give you the exact same probabilities. See the links below for additional supports and resources, and the link to the online calculator. Thanks for watching, and be sure to like and subscribe to get the latest videos from Caz Academy. I'll see you at the next video.